Data provides the foundation for GIS and this geographic approach. The geographic approach, looking at the world in a holistic, geospatial way, solving problems of our modern 21st century world. Accessing the data, as you can see here in the upper right, is so central to it. How do you visualize and map things if you don't have the data to begin with? The data is the starting point, and often, as I'll talk about later on, a way of keeping your inquiry going, because you ask different questions and new questions and tweak your existing questions, and then you have to acquire oftentimes data to answer those questions. Ultimately, this leads to action. Now, we're not doing this GIS activity for just gaining more head knowledge. We're trying to make smarter, wiser, more sustainable decisions so we can build a happier, more resilient, more equitable world. That is the whole purpose of GIS, to understand our complex planet and to take action to make it a better place for everyone. I would also submit to you all that data enables this holistic, interdisciplinary view that is needed. Specialization is good. We need people that understand soil and energy and water and biomes and population demographics, etc. But we also need people that have that understand a holistic view of the world, and if you adjust one variable, other things on the planet, under the planet, over the planet, etc., and the people that are living on that planet are affected. So how do we make smart decisions so that we're reducing the harmful side effects, but we are augmenting the positive effects? So this data is central to our geographic approach and our geographic understanding of how the world works and should work, and how we want the world to be. Data enables GIS as this common language for solving problems. One could argue that in some ways music is a common language of the world, but there's lots of different kinds of music and people like different kinds of music, etc. Geospatial maps and map-based understandings, spatial understandings, can be our common language for solving problems. And indeed, there are hundreds of case studies out there showing how organizations have come together to solve problems around this approach, seeing the world as one single ecosystem. And data, again, enables that to happen. Some of you may recognize this. Data has always been important to spatial analysis. This is the John Snow cholera map from 1854. John Snow was a very data-centric person, said, I'm going to map the cholera cases, which unfortunately almost always led to death then, in Soho and London on a map. Is there any relationship between the public water pumps and those cholera deaths? So using maps as analytical tools, not just maps as a reference document. Where is Soho? Where is Shanghai? Where is Rio de Janeiro? Using maps as analytical tools is what we're focused on here. And to do that, we have to have maps tied to data in order for all those analytics to run. And also, today, everyone is not just a data consumer, as in the past. In the past, only certain organizations could make geospatial data. Mapping agencies, science agencies, because they had the equipment and the knowledge to do it. Nowadays, everyone is a potential data creator through a variety of ways, through web-based GIS. This has huge implications of everyone being a potential data creator. We're going to dig into some of those here in this presentation. But I wanted to show you this map because it shows that data has always been central to map-based spatial thinking. Let's get practical now. How can you find data in this modern GIS era? Here are some challenges. Data needs are often very specialized in theme, scale, region, attributes, and other characteristics. Because projects and problems have certain specifications, certain paradigms, certain boundaries. Often it is difficult to find a similar need by someone else online. So it's hard to find their workflow, their problem that they tried to solve and how they grappled with data to do it. Third, the ephemeral nature of the web, things being temporary, discussion boards, etc., it makes it challenging to learn from other strategies. Despite the challenges, though, Here are some amazing things enabling data at your fingertips, data at your fingertips. First, data are increasingly collected and available in a wider variety of formats and, as I indicated earlier, as services. Second, data is increasingly being seen by organizations, nonprofits, government agencies, academia, private companies as an asset, not as something to charge for and kind of hold dear, near and dear, but to serve for the benefit of all decision makers. And third, open data portal technology such as ArcGIS Hub makes it easier for organizations to serve and curate data. In the past, again, it was difficult for them to do that, but these advances in tools and technologies such as Hub enable them to do it. The benefit for you and I as data consumers is that we've got those Hub sites available and other data portals. Just as there is often no single best source for one specific topic on the web, no single geospatial goldmine exists. I wanted to tell you that right up front here. That is the end-all site for spatial data. I actually, though, think that this is a good thing. Why? Because it forces data users to think critically about the data sets and the choices that they need to make. As I make clear on our Spatial Reserves data blog, choices abound. Those choices require the user to investigate and evaluate each of those data sources, determining fitness for use, which we'll talk about in a moment. Geospatial One-Stop and Data.gov were attempts in the USA to create a one-stop shop for data. Data.gov still exists and is useful. There were collaboration challenges in setting these up and other one-stop shops. Now, as we will see, the ArcGIS Living Atlas of the world is, in my view, the closest thing to a one-stop shop. Over 8,000 curated living atlas data layers, maps, and apps. I thought it would be helpful to share some words of advice. Minimize the search time for geospatial data so that you will have maximized the time available for your data analysis. However, don't shortchange your data searching by choosing only the data sets that are easy to obtain. Best available data, BAD data, BAD, best available data is oftentimes referred to as bad data. In other words, data that's easy to obtain and you get it right that and you don't really think about what other sources might be around. Remember, all of your decisions will be based on the quality of the data that you acquire. So data quality matters, spending some time acquiring, assessing matters. Also consider the software you are using and seek to minimize the amount of data conversion that you will have to do. Another reason to use the Living Atlas of the world if you're using Esri software. Let's discuss specific strategies that could be important no matter what data you are seeking to find and use. More data is not always better, okay? That is the bottom line of this slide, and I'm going to return to this in a minute. But first of all, have a clear vision of the data you need, the scale, the date or dates, the extent, the resolution, and other characteristics before you spend time just sort of plunging in and searching. Just like when you go in the field, you have the equipment, you have the units that you're going to use, the data you're going to collect, you have a plan. So same thing with data. Don't just plunge in. Have a clear vision of what you need and what will satisfy your project requirements. Also set a limit on how much time you will devote to searching and processing before the analysis stage. Otherwise, it's sort of like the ether. A data search can consume all of your project's available time. And again, more data is not always better. Do you really need 30 centimeter imagery for your regional study? Do you need higher resolution, more attributes, more layers? Not always. Focus on the data you need to get the job done. As we continue with my advice on strategy, number 2, when you find a potential data source, examine it carefully so that you can decide if and how to use it. To help you decide, there is this graphical aid to assist in deciding whether data can be used, and also this set of 30 checks for data quality in a potential source. I recommend to start searching with the Living Atlas, the ArcGIS Living Atlas of the world, for a variety of reasons that I'll explain in a moment. It is the closest thing to a one-stop shop. Now, why do this? First of all, the content. 8,000 curated and living data layers, maps, and apps, served in a searchable, easy-to-find way, with little thumbnails, metadata, etc. Ease of use. The maps, apps, and data layers are ready for immediate use in ArcGIS Online, ArcGIS Pro, and other applications. Third, the content is rich in metadata. You've got documentation as to who created it, how it was created, what the date was, how often is it updated, why it was created, etc. And it's hosted by authoritative sources, NOAA, USGS, the United Nations Environment Program, nonprofits, academia, local to international government agencies and everything in between, and private companies. Now, living implies two things. Number one, the content is continually being reanalyzed and curated, and the content reflects our dynamic planet Earth. Many of the data layers are updated in real time or near real time: weather, storms, earthquakes, volcanoes, traffic, stream gauges, and much more. Now, if you don't want to save time and effort, by all means, skip the Living Atlas. Haha, just kidding. I would highly recommend stopping here first. Number 4, investigate ArcGIS Hub sites. ArcGIS Hubs have emerged as a viable and easy way for organizations to host data, and as a result, thousands of them exist. What do I mean by them? I mean ArcGIS Hub sites. You can look in the URL, hub.arcgis.com, and that's a hub site. Plus, hub sites usually offer an array of downloading and streaming data options. Starting points include searching your area of interest and then GIS Data Portal or ArcGIS Hub in a Google search, for example. As one of hundreds of examples, here is the Boulder County ArcGIS Hub. There's thousands of examples, actually. There are also useful starting points, such as ArcGIS Hub search tools and galleries. Number 5, investigate selected top 10 lists that I've curated, such as top 10 satellite imagery, top 10 Landsat data portals, top 10 vector data portals, in terms of how useful are they on the Spatial Reserves blog. Number 6, investigate portals organized by theme that cover your topic, such as World Resources Institute on land use and natural resources, or the National Renewable Energy Lab's renewable energy data. So whatever your topic is, find organizations that are likely to host that kind of data, and usually they have a GIS or a data node on their websites. Number 7, investigate portals organized by location that would cover at least in part your study area. So location matters, start with location. If none of these other things that I mentioned earlier are helpful, you're in number 7 now. For example, the Ordnance Survey for the UK, if you've got a UK study, or state, province, region, or city examples. Here for Oregon, here for a large city, Los Angeles, and here for a small city of Oak Hill, West Virginia. Number 8, use Business Analyst Web as a data source for multiple countries, for hundreds of demographics, business locations, and behavior variables, health, expenditures, lifestyle, and much more. This is a tremendous resource, and it's oftentimes overlooked if you're not in business. But I'm just here to tell you that no matter what field you're in, you're going to find some treasures in there in terms of data. That's one of the best things about Business Analyst Web. It's online, the data is rich and varied, and it's for multiple countries. And it's also updated and has projections on demographics and other variables into the future as well. Here's some documentation on the data sets that are at your fingertips in Business Analyst Web. Number 9, because an increasing amount of research is tied to geospatial data, I've got a couple of blog posts about this. Research tied to data. Check Google Scholar, library databases, and other sources of peer-reviewed research, as well as conference proceedings from ESRI, the American Geophysical Union, American Association of Geographers, and other major events to investigate those sources identified in the research. Now, be tenacious on this part because there are some inherent challenges with obtaining data tied to scholarly research. This is a relatively new movement. In the past, much research was published and you don't have access, the reader doesn't have access to the data for a variety of reasons that we could talk about. But increasingly, there's pressure on researchers to provide the data so someone can replicate your study in a different area or with different variables, etc. So don't neglect this one, even if it's a bit difficult at the present time.